Welcome to the ChemDoctor, and what I'd like to do in this presentation is go ahead and continue practicing writing line drawings from the condensed formulas of organic compounds. And this is the second video in the series on O-chem. And so what I would like to do is we'll start with the name of a particular compound. We'll convert that name into the condensed formula, and then we'll convert the condensed formula into a line drawing. So let's go ahead and get started. The first compound that we're going to work with is called 2-methylheptane. Now, when you look at the name here, the thing that you've got to sort of wrap your mind around is how the naming actually works. So the section here at the end gives us the actual number of carbons in the parent chain. So we're dealing with heptane here, which means that we're dealing with a compound that actually has 7 carbons in it. So what I normally do when I'm going to convert from the name to the formula is I will establish my backbone by simply writing the carbons down, the right number of carbons for the parent chain or for the backbone. So what I'm going to do here is get myself 7 carbons. So let's see, we have 1, 2, 3, 4, 5, 6. Here's the 7th one. And then I'm going to establish where my branch is. And to do that, I need to focus on the information that we have here on the front end of the name. So this number is going to tell us which carbon that this alkyl group, right, this alkyl functional group is present. And so the methyl group that is attached to this heptane chain will appear on the 2nd carbon. So I'm going to go ahead and add that here. And for simplicity, I'm going to go ahead and count in from the left side of the chain. That's normally what I do. So let's go ahead and put our methyl group here. And now what we need to do is go ahead and add the hydrogens for the rest of the compound. So there's going to be 3 hydrogens here. Remember that we need a total of 4 bonds around each carbon. There's going to be a single hydrogen here because this carbon is already attached to 2 other carbons and this methyl group. That's a total of 3 bonds. So we need to add 1 more hydrogen here. These carbons in the middle are all going to need 2 more hydrogens to establish a total of 4 bonds around each carbon. So we'll go ahead and add those in, and then the terminal carbon here on the end is going to be CH3. Now to get to the line drawing, remember a line drawing is only going to show the carbon backbone, and by convention, the hydrogens are not shown. So let's go ahead. I'm going to count again. It's 1, 2, 3, 4, 5, 6, and 7. So my line drawing is going to be, there's two carbons, 3, 4, 5, 6, and 7. All right, now we need to go ahead and put this methyl group in. And again, the methyl group is going to appear on the 2nd carbon in, and I'm going to come in from the left. And I'm going to change the color just to emphasize the addition of that. So this is what the line drawing is going to look like, and maybe just for some more clarification, I'll number the carbons. So this is 1. This is the 2nd carbon in on the chain, 3, 4, 5, 6, and 7. And my methyl group is at the 2nd position in the chain. All right? Okay, let's move on to the next one. Now this next one is 2,2-dimethylpropane. So propane is my parent chain. Again, what I'm going to do is lay down my 3 carbons, which are my backbone. We have 2 methyl groups. That's what the di means. And we know that both of the methyl groups are on the 2nd carbon into the chain. So let's go ahead and add those. I'll put 1 below and 1 above. And then this terminal carbon here is going to be CH3. And this carbon here is also going to be CH3. All right, and let me go ahead and connect this bond so you don't think I deliberately gapped this in some weird kind of way. Now, in order to write the line diagram for this, I'm going to have, it's a 3 carbon unit, so we're going to, there's 2 carbons there, and here's my 3rd one. And then off of the central carbon, there needs to be 2 methyl groups. So we'll have one like this, and one like that. Actually, I think I can do a better job drawing that. Let me fix this so it looks better. All right, so we're going to have one of the methyl groups coming here and one of the methyl groups coming there. All right, so we should have a total, in this molecule, we should have a total of 1, 2, 3, 4, 5 total carbons. 1, 2, 3, 4, 5 carbons, all right? All right, so that completes this one. Let's move on to the next one. So in this particular molecule now, this is butanol, right? This O-all here, let me change the color so I can emphasize this. The O-all here, this is an alcohol functional group, so we're going to be adding what we call a hydroxyl to this particular molecule. All right, and how do we know our parent chain? Because it's butan, which comes from butane. So we're going to have a 4-carbon unit here. Let me go ahead and I'm going to put my backbone in. There's the 4 carbons. The OH group, or the hydroxyl, needs to be on the 2nd position. So let's go ahead and put that on the 2nd carbon. And again, I always come in from my left side. So here's my OH at the 2nd position, and now we need to add the hydrogens. So on this 1st carbon here, in order to have 4 bonds, we're going to add CH3. This carbon, the second one in, is going to need 4 bonds, so we're going to need exactly 1 hydrogen here. There's going to be 2 hydrogens at this position, and then again there will be 3 hydrogens on the terminal carbon. All right, and then for my line drawing, I need a total of 4 carbons, so there's 2, 3, and 4. And the hydroxyl group, I'll change the color to emphasize this, is going to be off the 2nd carbon, like this. All right, so this is going to be 2-butanol. And just for the sake of clarity, I think just in case the viewer is not sure about how I'm dealing with these hydrogens, let me quickly draw the expanded structure of this thing, all right? So the expanded Lewis formula would look like this. So you can see that single hydrogen extending down off the bottom of that, and then we're going to have our CH2 group here, and then finally another carbon that has 3 hydrogens on it. All right, so that should help you relate this structure to what I'm doing in these condensed formulas. All right, so now let's go ahead and move on to the last problem. In this one, we have a new functional group here. Let me use a bright color to emphasize this. It's an ene, so that means we're going to have a double bond in the molecule somewhere, and the somewhere will be at the 2nd position. So the double bond will take off from the 2nd carbon. The backbone is pent, which comes from pentane. So let's go ahead and I will put in my backbone. So there's going to be a total of 5 carbons. I'll do it this way. The double bond is going to be in the 2nd position, so let's go ahead and put this in. All right, the 1st carbon is going to have a total of 3 hydrogens to it. The 2nd carbon, in order to have 4 bonds, it will have a single hydrogen, so I'm going to put it up here like this. This guy here will have a single hydrogen, so I'll put it like that. This carbon is going to have 2 hydrogens to it, and this carbon is going to have 3 hydrogens to it. So now if I go ahead and I draw my line drawing, all right, it needs to have a total of 5 carbons. There's 2, 3, 4, and 5. My double bond is going to be in the 2nd position, so we'll go ahead and we'll put it here like that. All right. This is a reasonable representation of the molecule as a line drawing. All right, and you can compare what I did here to the expanded Lewis formula that I drew over here, so that may help you understand the issues with the hydrogens. All right, now With that, I'd like to go ahead and close this video, and I will follow this video with another one with actually probably several more, so we can practice this, going from names to condensed formulas to line drawings. I'd like to thank you for watching the video, and you can find more videos at www.chemdoctor.org.